So these are different EUIs, 49, 60, and 113 for school, office, and prison here in Phoenix zip code. And this is based on a simple design using a software called Autodesk Vasari, which I'll talk about, to estimate your building's design. The reason why I'm bringing this up is until now, all the EUI we talked about is the average building's EUI, right? What's out there. So you know what's out there. Let's say it's 60 for an elementary school. But you need to know what your building is so that you can compare how far off I am. And then you can try to bring it down to meet your targets, right? So in order to know what your building's EUI is, there is no other way other than using any of these tools. You have to use a tool to come up with what your EUI is. There are millions of tools to do this. And we're going to talk about one tool that makes it much more easier than any other tool, which is Autodesk Vasari.
Say that again. What is it?
Autodesk Vasari, V-A-S-A-R-I. And the reason why I'm thinking it's much easier is because it is Revit. It's in Revit. And right now, the Revit that we use, Revit 2011, has this feature in it. Okay? So we're going to talk about that. So first of all, at the big picture level, to answer this, where can my design reduce EUI? We first need to understand the fuel source. Do I have electricity or natural gas? All these simulations of my building design, one for school, one for office, one for prison. The prison is at 460,000 square feet. The office is 20,000 square feet, and the school is 70,000 square feet. Let's say this is an elementary school, okay? So with these data, I was able to plug this into Autodesk Vasari and come up with this EUI, assuming I have both natural gas and electricity. So this is in Phoenix again. Take a look at this 49 EUI. For school, only 13, which is, what is the percentage? Less than 25% is towards natural gas. Everything else is electricity. Go to the other extreme. Prison, almost half of it, or more than half of it, is natural gas, and the rest is electricity. When you come down to the office, very tiny portion is natural gas. The rest is all electricity. So is this good information to know to begin with? Right? So will it help you to understand, okay, do I really want to mess with natural gas in an office building? Because it's only a tiny little portion. Maybe I will just deal with, if natural gas costs are really high, and bringing a new meter, you're just somewhere out there and the pipeline costs a lot. Knowing this, it's only 10% of your energy. Do you really want to consider that? Well, you may. Why?
It's the best energy source. It's the most efficient.
Correct. Correct. So that's one aspect of it. So we're going to try to balance all these different factors and try to finalize an answer. But this is also one factor to consider because natural gas is only 10% of an office. But look at this. Why is natural gas a huge consumption in prison?
The water heaters usually are boilers, gas-fired, and then the kitchen, and then laundry.
Yes. Yes. Because there's a lot of domestic hot water load in a prison as compared to an office or a school. School, there is a gymnasium, because this is just for a normal school. It doesn't differentiate between elementary school and middle school and high school. But in a typical school, let's say high school, you're going to have shower load. So that's where some of this domestic hot water load is.
And
So
the kitchen.
Kitchens also. So far everyone on the same page? Okay. So I think it's important to start breaking these down into simpler portions so we can understand how this will inform design. Okay? So we looked at the different fuel sources, electricity and natural gas. Within electricity and within natural gas, what comprises that load? Why do we have 13 kilobitu's per square feet. There are two types of natural gas uses. One is the building heating, and the other is the domestic hot water heat, right? Typically. So if you break that just a natural gas portion and break it down further and try to understand what these different uses are, now look what happens. In a prison, 94% of your natural gas consumption in Phoenix is towards domestic hot water. So that's all your laundry, that's your kitchen, that's your showers and sinks all over the place, right? Go to an office, only 30%, because we only have few sinks, and most offices don't have showers. So most of the natural gas goes to heating, right? So now, knowing this information and knowing the previous chart, will you put a solar hot water on an office building in Phoenix?
Yeah.
Only if it makes sense from an economic standpoint, right? Because you're only dealing with 30% of 6 kBTUs, which is practically nothing. So is it important? Is it the best use of the client's money to invest in solar hot water to provide this? So you should ask that question. It may be the best here. Look at this. This is 94% of half of the prison's energy use.
It is a practical on the prison.
I'm sorry?
If you're using so much to heat water, is it practical to cover the entire roof with solar water
No.
heating?
Typically,
Also,
when we design solar hot water for any building, we always design for about 60% or 70%, because we cannot completely rely on solar hot water. Because what if the sun's not there during the coldest months? You're screwed, right? Right? Okay. So knowing this information, I'm just pulling out an example here. Your project type might be different. So understanding what your building consumes and what the breakdown of EUI is very, very important to begin with before you start tackling different solutions to solve the problem. Is everybody on the same page? Okay? All right, so that's natural gas. Let's get on to electricity. So there are three major ways to look at electric consumption. One, the equipment, your computers and scanners and whatnot that you have, and lighting. And then the last one is the cooling energy, because heating is taken care of in natural gas. It's the cooling energy and the ventilation as far as how much air we're bringing in, right? So look at this among the three different types. What is pretty obvious to you? Equipment is pretty consistent among these guys, right? The amount of energy the equipment consumes. Do we, as design professionals, have a say on what goes into reducing this portion of the pie? Not really, right? Because it is what it is. Computers are computers. They are going to need energy. They're going to need power, and they're going to release heat. So right off the bat, you can say my design can only impact 70% of the electricity usage in a school. Is that good information to know? Do you think? Right? Because let's say let's say a product salesperson comes in and tells you that by going to a different product, I'm going to save you 30%. Let's say it's a glazing system. Now you know 30% of what? Because that 30% is only some portion of this 40%. Do you follow what I'm saying? So it's really not a huge deal. Or really, it may be a huge deal. It depends. But at least it will give you a gauge on how to use this number. How to use different fractions of EUI. Am I boring you guys?
Greg, just where do these breakouts come from?
This is from the energy model. This is what your energy analysis tool will tell you. And that's why it's important to do a preliminary dumb, no design, just a dumb box of whatever project type that you're doing, and put it into the the energy analysis tool, and find out this breakdown first before you start analyzing what the hell to do. Yes.
Isn't that 30% actually in terms of equipment, actually even, we have less of the piping control because then the percentage of equipment right now, I know you show it about 30, but it really contributes to the cooling. So the number, if I have more than you have, and you have to cool because there's
Yes.
getting more heat, so then
Yep.
the result is, it's not quite 70, I guess I'm seeing it's less than 70 in terms of its
Actual-
controllability or
right.
what we can reduce.
Right, and I'm going to talk about how we can, as design professionals, impact this, because this is assuming a certain number of PCs, a certain number of equipment for this building type. We as designers, we can help the clients try to reduce this through using Energy Star equipment, flat monitors or something, right? We can help them. So we'll talk about that later under energy modeling. But it's important to understand the breakdown. And this breakdown may change slightly based on how you put your building, and it could change based on your zip code, because the cooling energy and the heating energy changes a lot. So that's why it's very important to just have a simple box of what your building square footage is and put it on your zip code and find out what the energy breakdown is.
In a school, you're going to have a lot of kitchen equipment. And so it's going to be gas or it could be electric. But it's a fairly,
Right.
it's a big drain on. If you just looked at computers, while the energy used for the actual computer, but the heat that's generated
Yep.
off the computer, isn't that, where does that fall into that?
That will, the
Does
heat
that
that's,
fit into that number, or is that
Right,
fit into
the-
the cooling ventilation number?
that'll be in the cooling ventilation number.
As a part of the equipment?
Right. So equipment has two types of energy consumption, right? One is the actual power,
Right.
and then the heat it puts out. So the heat it puts out has to be controlled by the cooling number. It actually will help here to reduce natural gas consumption on the heating side. So we'll talk about that in a second. So equipment is pretty easy to understand. It is all the equipment. Lighting is easy to understand. But what is this cooling and ventilation? How do I get 40%? And how do I get this 10%? There are different factors that contribute to this 10% and this 40%, right?